Hello guys, welcome to the next video of Exploratory Data Analysis series. So in this video guys, we will discuss on the bivariate analysis. So let's move ahead in this particular video. Okay, so guys, in the univariate analysis, what we had done is that we had made an analysis using a single feature. Okay, now as the word suggests, bivariate analysis, we will be using the two features simultaneously and make an analysis. Okay, that's what we will be doing. Now, in this process of bivariate analysis, we will be plotting different types of plot known as scatter plot, pair plot and all. So let's begin with the scatter plot. Okay, so well and good. So first of all, we are setting the style. We are again using our Habermann library. Okay, we are using the Habermann dataset, Habermann, and again here we are having a scatter plot. So plot dot scatter. Okay, and what we are doing, we are using the two features here, age and the operation year. Okay, so what this is the scatter plot among two features known as age and operation year. Okay, and this is the scatter plot. Okay, now let's look at the analysis part. Now let's look at the main part is that we must have the sharp eyes. Okay, we must be able to analyze the given graph, the given plot. That is one of the best quality a data scientist have. Okay, so we can see there's a huge overlap here. There's overlap of around 80 to 90% as I see from a naked eye. So I don't think that we will be able to classify the survival status of patient where blue represent yes and orange represent no on the basis of this age and the operation year feature. Okay, so that's pretty hard. Now let's move to the next plot here. Here we are plotting it is scatter plot among two features known as age and the axial node. Okay, and here again we can see there is an overlap of around 80 to 85%. So we can see there are few outliers lying and there is more overlap in this particular region. So definitely this is also a pretty cool graph to classify the survival status of our patient based on the axial nodes and the age. So that is pretty hard again. Okay, so now let's look at the third plot here. The third plot is again a scatter plot in between two features known as axial nodes and the operation year. And this is not so overlapping plot. We can still define something here. There's overlap of around 90 to 95% in this very particular graph as well. So definitely it is also difficult here to classify the survival status of patient who had undergone the breast surgery on the basis of the operation year and the axial nodes. So again, it's pretty hard here again. Now let's look at the next class of plot known as pair plot. Okay, so again here we are setting the style and it is a pair plot. So we are again using the Habermann library SNS.pair plot. Okay, so yeah, in the pair plot what we are doing is that we are using all the features together. Okay, we are using all the features together. Okay, that is along x-axis we have age, operation year and axial node, and again along y-axis we have age, operation year and axial node. Okay, and this is a pure plot of all the features against one another. Okay, this is the beauty of pair plot. Now let's look at this particular pair plot. Okay, now let me show you. Look, along y-axis we have age, operation year and axial node, and again along x-axis we have age, operation year and axial node. Okay, this is a particular, we can say this is a particular PDF plots, and these are the particular, we can say, scatter plots. And on combining these two things, we are getting our particular pair plot of Habermann data. So what are the conclusions we are getting from this particular plot? Let's see. It is very difficult to predict the survival status of patient who had undergone surgery for breast cancer on the basis of the three features, that is age, operation year and axial nodes, because both of the classes 1 and 2 are almost 80 to 95 to around like or almost around 85 to 90% overlapping with each other. Yeah, definitely we can say look, it is highly overlapping. Again it is highly overlapping here, and again we can say it is also a bit of overlapping, but we can see some part are still left which you can analyze. We will see this part. Okay, don't worry. So these two classes are linearly inseparable due to intense overlapping. We should collect more useful features which are helpful in predicting the survival status of patient who has undergone the surgery for breast cancer. Definitely we need more useful features now, and we need to use non-linear models. Then only I think we can predict the survival status of patient. And yeah, Excel node is around 20% more useful feature than agent operation here. Yeah, we have seen this in our box plot, in our Valin plot, and I feel it is also seen in our particular peer plot as well. Okay, we can see there's less overlapping while we have the Excel node plot, okay, along this very graph as we see here. So definitely Excel node is probably the most important feature here. So the order of usefulness of feature, we can, as we see in this particular analysis, is Excel node followed by operation year followed by age. Okay, this is what is the final conclusion we got. What is the order of usefulness of features? It is Excel node followed by operation year followed by age. So what are the conclusions? Not linearly separable. We need to use non-linear models for better prediction, and Excel node is till now Excel node is the most useful feature. And yes, we need to create more useful features which can help us in our analysis part. So guys, this is the entire case study of Habermann dataset, where we have gone through different plots, and this is the complete case study where you are getting the full-fledged knowledge of exploratory data analysis, which is the beginning part of any data science or machine learning project. So hope you guys love this case study, and if you guys have any doubt related to this case study, you guys can leave your doubts in the comment section below. I will be more than happy to solve your queries. So this for now. I will come again with the next case study or with the next video in the next session. So yeah, love you guys, and I need your love and support. So yeah, see you guys in the next video. Love you all.